All right, first page of notes, we have an introduction to what's called inscribed angles. So an inscribed angle is an angle whose vertex is on the circle. So if you recall, the vertex of, if we're looking at this picture here, the vertex of this angle ABC, the vertex would be B. So if we were trying to kind of give an example, we can kind of draw, I'll give you some more pictures of what an inscribed angle might look like. So this might be an example of an inscribed angle. This might be an example of an inscribed angle. So for all of these, you have a vertex that touches the outside of the circle. Now, previously we learned about central angles, and I'm going to draw that up here so you don't get confused. A central angle was an angle whose vertex was at the center of the circle. So it looked something like this. All right, so for example 1, it says in the figure to the right, find the intercepted arc and the measure for each of the following angles. So if QPA is the inscribed angle, what is the intercepted arc? So we have Q, P, and A. The intercepted arc here is going to be arc AQ. Or you could say QA. Same thing. Next, it says if QPB is the inscribed angle, what is the intercepted arc? So we have Q, P, B. That's our angle, so our arc is going to be BQ or QB. Next one. See if you could, go ahead, why don't, at this point, you should pause the video and see if you can do C, D, and E. See if you can figure out the intercepted arc. And then for E, they give you the intercepted arc, and you have to find the inscribed angle. So see if you can figure those out. So go ahead and pause it. Try it yourselves. So for C, we have D, G, A. So we go like this. D, G, A. So that one's not written in there. You have to draw it yourself. If that's the inscribed angle, our intercepted arc is going to be DA or AD. Then we have QGA. Q, G, A. Again, our intercepted arc is going to be AQ or QA. Then the last one, if PG is the intercepted arc, what could be the inscribed angle? So let's take a look at that. If we have PG is our arc, we actually have quite a few options for our angle. There's actually several you could give me. I'm just going to give you some examples of what you may have given me. We have PGB, and you have to write that as an angle, right? So PBG. I'll do another one in a different color. We also could have said PAG. And we also could have done, let's see, we'll do PQG. All right. And then we got the last one on this page. If arc CB is the intercepted arc, what could be the inscribed angle? So we have CB. So some of our options for an inscribed angle could be CPB. We could also have CGB. We also could have CQB. All right. So for all of these, they have the vertex on the the vertex is a point on the circle. You may have gotten some different answers for E and F. There's kind of, many different combinations you could have given. So let's go ahead and try to essentially define what an inscribed angle is. All right, so if we're looking here, it says, what is the inscribed angle? So if we look here, our inscribed angle is going to be A, B, C. So our inscribed angle is angle ABC, or CBA. What is the intercepted arc? Well, the intercepted arc is AC. All right, and for this one, the theorem is that 2 times the measure of the inscribed angle is equal to the measure of the intercepted arc. So what does that mean? This 2x is going to be equal to 82. 2 times the measure, right, of our inscribed angle, which in this case is x. So 2 times that is going to equal the intercepted arc. Now, if you recall, for central angles, the angle was equal. Ooh, I wanted a circle, not a square. The angle was equal to the arc, right? If we had this, right, if I said this was 82, then my angle was 82, right? But in this case, my angle is actually going to be equal to 41 degrees because it's equal to half the measure of the arc. So let's go ahead and try example 1. It says, use the diagram to answer the following questions. What is the inscribed angle? So they're asking for the angle. In this case, we have angle Z, Y, X. What is the intercepted arc? We have arc Z, W, X. And it says, set up and solve for Z, W, X. Well, we know that twice the angle is equal to the measure of the arc. Now, keep in mind, the angle is always, for these inscribed angles, the angle is smaller than the measure of the arc, right? So you just do 115 times 2. And that's going to give us the measure of Z, W, X, which in this case should give us 230 degrees. Next, it says, what is the measure of angle ACB? So they're asking for the measure of this angle. All right. So what we can do here is go ahead and actually solve for AB. And then I should say for arc AB. And then we just cut that in half to find angle ACB. So what we're going to do is we know that all the way around the circle is going to give us 360. So we're going to do 360 minus 89 minus 153. And with that, we should get 118 degrees. So we know that AB is equal to 118. Since angle ACB is an inscribed angle, that's going to be equal to half the arc length, right? Because the arc length, or the arc measurement, is twice that of the angle. So we just do 118 divided by 2, and you get 59 degrees. All right, next. Let's see if you can do this one. All right, it asks what the inscribed angle is, what the intercepted arc is, and then it asks you to solve for the inscribed angle. Now keep in mind, the inscribed angle is equal to half that of the arc, right? When we're dealing with inscribed angles, they're always half the arc measurement. So go ahead, pause the video, see if you can do this one. So to answer this question, it says, what is the inscribed angle? Well, our inscribed angle is angle NMP. The intercepted arc is NP. Then it says to set up and solve for NP. Well, we're trying to solve for this, right? And we know that 2 times that needs to give us 100. So x equals 50 degrees. Right? The measure of the inscribed angle is half the measure of the arc. So for number 4, use a diagram to answer the following questions. What is the inscribed angle? So this one actually isn't labeled, so what we'll do is we'll just highlight it. This is our inscribed angle here. Our intercepted arc is going to be this guy. Now it says set up and solve for x. Well, we know that this inscribed angle needs to equal half the measure of our arc. So we know that this angle has to equal 208 divided by 2. 208 divided by 2 is 104. So you just do 5x plus 4 equals 104. Going with 5x equals 100. X equals 20. And that would be your answer there. Next, for our last example. Now, there's something I want you to kind of take away here. You're going to see pictures like this, both on, standardized tests and assessments that you're going to have in school. Here, we have 2 different inscribed angles. I'm going to highlight them in different colors. Notice how they intercept the same arc, right? They're different angles, but they intercept this same arc, right? This red guy intercepts this arc, and the green guy intercepts this arc. So when that happens, you know that these inscribed angles are automatically congruent, and that's something that you need to know. So this one says to set up and solve for y. Well, y is an inscribed angle, so that has to be half the measure of the arc. So we just say 2y equals 98. Y equals 49. Then it tells us to go ahead and solve for x. So in this case, what we can do is they're asking for this inscribed angle. Notice there's several inscribed angles in this picture. If we're solving for x, we know that x has to be twice the measure of the inscribed angle because x is going to be equal to the arc length. So we just do 2 times 30 equals x. X equals 60 degrees. So to kind of summarize what I just went over, the idea is that for an inscribed angle, that is going to be half the measure of the intercepted arc, and vice versa. The intercepted arc is twice the measure of the inscribed angle. So just keep in mind that the inscribed angle should always be smaller. The angle is smaller than the arc in this case.